Welcome back to another learning series with Mr. Knight. Today we're looking at metals versus non-metals. By the end of this lesson, you should be able to determine if an element is a metal or a non-metal. Before you can do this, there are a number of things I need you to know. You need to know the atomic number of the element. The atomic number will help you to determine the number of electrons and also the number of protons. The number of electrons are very important for this lesson. When you look in the periodic table, you will see two numbers. The smallest number is the atomic number, and it is equivalent to the number of electrons. You also need to know the electronic configuration. The electronic configuration is the arrangement of the electrons within the atom. You also need to know the number of valence electron or electrons or the group in which an element is placed in. The valence electrons are those electrons that are found on the last shell or the valence shell of the element. Now, looking at the atomic structure right here, you will notice you'll see 2 electrons on the first shell and 5 electrons on the last shell. So this last shell is called the valence shell. So let's look at this example with nitrogen. Nitrogen has 7 electrons, which means the atomic number in the periodic table will be 7. To distribute these electrons, you follow the rules for doing electronic configuration. And if you do not understand how to do electronic configuration, you can view my lesson on electronic configuration. So to distribute these electrons, you'll put 2 on the first shell, which is the maximum, and the remaining 5 will be placed on the second shell, which will be the last shell or the valence shell. So it turns out to be, based on this atomic structure, that the number of valence electrons for nitrogen will be 5. It also turns out to be that nitrogen will be in group 5 because the number of valence electrons determine which group the element is placed in. So take, for example, if an element has 7 valence electrons, it is in group 7. If an element has, say, 2 valence electrons, then it can be found in group 2, and so on. Now, very important to note in terms of classifying metals and non-metals is that metals have 1, 2, or 3 valence electron or electrons, while non-metals will have 5, 6, or 7 valence electrons. So take, for example, magnesium that has 12 electrons. I am displaying the valence electrons in red for ease of viewing and also understanding. The first shell has 2 electrons, the second shell has 8, and the last shell has 2. Therefore, since there are 2 valence electrons, magnesium is a metal. Let's look at this example for sulfur. Sulfur has 16 electrons, 2 on its first shell, that's the maximum, 8 on the second shell, and the remaining 6 on the third shell or the last shell, which is known as the valence shell. Since there are 6 valence electrons for sulfur, sulfur is a nonmetal. Now, once you understand this, now it's time for you to practice. So you could pause the video, determine which of these elements is a metal or a nonmetal. Now let's look at the first one, sodium. Sodium has 11 electrons. Out of this 11 electrons, 2 will be placed on the first shell, 8 on the second shell, and 1 on the last shell. So therefore, since there's only one valence electron, then it is a metal. Phosphorus, for example, look carefully, 2 on its first shell, 8 on its second shell, and the remaining 5 on its last shell. Therefore, since there are 5 valence electrons, then phosphorus can be classified as a nonmetal. Great. Let's look at these two final examples. Let's look at chlorine that has 17 valence electrons. 2 on the first shell, 8 on the second shell, and the remaining 7 on the last shell. Since there are 7 valence electrons, then chlorine can be classified as a nonmetal. Let's look at this final example for helium. Is this a metal or nonmetal? Well, it cannot be classified as a metal or nonmetal, and it's for a very special reason. Now, I know you may be wondering, since it has 2 valence electrons, you may be wondering why it's not a metal. All right, very good. Now, for helium, which is an exception or a very unique element, is that it follows a rule that is known as the octet rule. The octet rule explains that if the valence shell is completely filled, then the element is classified as a noble gas or inert gas, which means the element is deemed unreactive. So helium, for example, which has 2 electrons, the 2 electrons are placed on the first shell. The first shell is also the valence shell. But since the first shell holds a maximum of 2, it therefore means this shell of helium is completely filled. It has only one shell, a matter of fact. And this one shell is its first shell and also its last shell. Therefore, the valence shell is completely filled and it is classified as a noble gas or inert gas. So this will be the exception within the periodic table. Now, since you master how to identify if an element is a metal or nonmetal, we now can look at the entire periodic table and group these elements as metal or nonmetal. All right, at this point, I'm only looking at the general concept. So, generally speaking, any element that falls in group 1, 2, or 3 are classified as metals. The elements between group 2 and group 3, they are classified as the transitional metals. Generally speaking, the elements that are in group 5, 6, or group 7, they are classified as nonmetals. I will be doing a lesson on the trends in the periodic table and the properties of the periodic table, and you'll realize that there are some exceptions, and we call those metalloids. But for now, the general rule, group 1, 2, and 3 are all metals. Group 5, 6, and 7 are classified as the nonmetals. Now, importantly to note are some properties of metals and nonmetals. Metals are generally shiny, while nonmetals are dull. Metals tend to be hard, nonmetals tend to be brittle, which means that they can break easily. Metals tend to be malleable and ductile, while nonmetals tend to be non-malleable and non-ductile. Malleability refers to the ability to be beaten into shape without being broken, while ductility refers to the ability to be drawn into wires. Metals tend to be good conductors, while nonmetals tend to be poor conductors. And the conductors I'm referring to at this point is the conductor of heat and also the conductor of electricity. So metals can conduct heat and electricity very well, while nonmetals cannot do it so good. Metals tend to be solid. Of course, there will be exception, which I'll look at when I'm looking at the periodic table in details, while nonmetals can be either solid, liquid, or gas. Now, at this point, you should be confident enough to be able to describe metals and nonmetals and also to identify which element is a metal or a nonmetal. So at this point, we're at the end of the lesson, and I'm looking forward to see you in the other lessons. So keep safe until we meet again.